Hey guys, in this video I'm going to talk about the two sample lab reports by Gunter Gudstudensson and Timmy turns in his first draftsman, and also I'm going to compare each of them to the laboratory requirements document and also talk a little bit about your first lab report for this class. So to begin with, Gunter's paper is pretty good, as you might imagine. His title is of the right kind, right? It uses science words, and the name of the title gives the names of the variables being studied. The purpose says what the lab's supposed to demonstrate, right? It doesn't just say, we rolled a cart down an incline, which is what they did in this hypothetical laboratory. That's not really a purpose, right? The purpose of the lab is not necessarily what you did, it's what the lab is supposed to demonstrate. Their diagram here and the math that they've done, handwritten and or drawn is fine. You don't need to take a picture of it and paste it in, anything like that. In fact, I would say don't do it in Notability, just put it on the paper. The formatting in general for Gunter's paper is pretty good, except for, right here in that spot, there's some white space. In general, you do not want to leave a bunch of white space using just extra paper for no good reason. Overall, his formatting is pretty great, but that's the one small ding against him I could find on formatting. The methods section is done the right way. The methods section should be a non-specific summary, meaning it shouldn't say, like Timmy's does, as we'll see, get this many physics textbooks. You don't need to specify that. It doesn't matter really how the cart was propped up. That's not important for the methods section. In his data, there are units. This is good. Anytime you're presenting data or results, those ought to have units, right? You can see there it's got the meters or centimeters or seconds, whatever it may be. Please note that for your first lab report in this class, there will not be this sample calculations section. That won't exist. The sample calculations section is for repetitive calculations. In this lab, they repeatedly calculated the angle, because that kept changing, and they kept calculating the acceleration of the cart, so it was a bunch of repetitive calculations that were the same thing over and over. That won't be the case for this first lab that you're doing for this class. You won't need a sample calculation section. Also, there won't be a data table for this first lab. Instead of a data table, it's just your graphs for the lab. That is your data. That is not typical for your labs. All right, and then let's keep on going down. His graphs are the half-page minimum, contain a title with words, have axes that have words and units, and there's a trend line for any linear graph. And then we're getting down to the discussion here. In the discussion section, there's always supposed to be a discussion of a significance, which relates back to the purpose of the lab. In other words, did what you did demonstrate the purpose that you said it was supposed to demonstrate? And in this case, the answer is yes. So that's what he wrote about. The other things here, I don't expect you to know anything in particular about whether his answers are right or not, because this is beyond what we've studied in the class. But he's answering the discussion questions, and more what I'm interested in you seeing is that the length that he is using here is what I consider to be the appropriate length. Multiple sentences with some amount of detail. Oh no, there's one typo there. Okay, it happens. The more words you write, the more typos you make. However, proofread. Ideally, you don't have typos because you have proofread and been very careful about it. Okay, when you are writing your sources of error section, it's sort of an unwritten rule that I'm going to just spell it out for you right now. I want 3 sources of error at least, 3 significant sources of error. Gunter has that. However, here's a ding against him. Error discussion should say how a source of error affects the results. It shouldn't just say, this was an error. It was a bad error. This bad the error was. You have to say how it is going to affect the results. He does this for some of the things. For example, he, when talking about friction, says there was certainly some frictional force that decreased the acceleration of our cart. Okay, so he has said friction would decrease the acceleration of the cart. Yes, he has correctly identified the effect of that source of error on the results. However, he does not do this for either of the other two errors. If he had just said something like a lower angle, like when he's talking about how the track would slip down over time or something like that, a lower angle would decrease the acceleration. That's an important thing to mention, and it's not there. So summarizing Gunter's paper then, his grade turned out pretty good. My rubric did leave off the methods section, which was an oversight on my part. So in fact, his paper should be out of 45 points, and I gave Gunter a very solid 44 out of 45. So really a very good paper in all respects. All right, let's see how Timmy fared. Timmy, true to his name, turned in his first draft and honestly may have spent about 15 minutes in all writing this thing. He didn't even try. His title is not a title. His formatting is wretched. If you're not sure either how you would do things like the Greek letter theta, or something like a subscript or a superscript, I'm going to make a separate video about how to do those kinds of particular things in Google Docs. This is terrible. If I see your entire screenshotted Notability screen, I don't know. That just looks extremely unprofessional. For that matter, his lack of using Greek letters and trying to type out the equations but badly also looks extremely unprofessional. It would look better handwritten. Honestly, handwriting it is fine. This is not. This is unreadable, really. Okay, the methods section. What Timmy has actually written here is a procedure, right? He said, do this, then do this, then do this, then do this, right? He's saying this is exactly what we did, and that is not a methods section. All right. Let's see, typos. I didn't expect you to necessarily catch that his height measurement here is not the right thing. But I would expect you to notice the lack of lines. This makes it hard to read, especially since the words are centered, but the numbers are not. Breaking a table across a page. Don't break a table across a page. What he has done for the graphs is the exact opposite of what Gunter did. All right, if I get this from you for the discussion, you deserve 0 points. This is bad. Just looking at this, I'm I don't even know what you're talking about. Yes, I have the discussion questions in front of me, but that's no excuse for just poor writing. You, when you write, should include context for your answer, right? What depends on the sign? It should say sign. And then for the sources of error section, this has none of the things I want to see in sources of error. I'm really not sure that he has 3 errors, and they're even barely discussed, right? Mentions friction, okay. Messed up our results. What do you mean by messed up? Did it make your results too big? Too small? Unpredictably big or small? Just more uncertain, right? That's a lot more informative and interesting than just saying, yeah, it messed it up. All right, now, if you're looking at the laboratory requirements document, which you should before writing your first lab report, and then you go back and you compare to each of the 2 reports, every time you're going to have a title, It's going to have your name, the names of your lab partners. It should have the date on which the experiment was performed. Gunter had all of those things. The title was descriptive and got full points. Timmy didn't have a proper title. It was just Force Lab. That's not really going to cut it, and was lacking a date. The purpose. Timmy's purpose was acceptable because it did say, in fact, what the lab was supposed to demonstrate. Gunter's was more articulate, but both got points there. For the theory section, there's always going to be specific questions that are asked in the introduction to the lab. When you answer them, generally speaking, you're going to have to use words. Sometimes you're also going to do math, but there really should always be some amount of words in your explanation for the answer. All right, materials, that's just list out the things used in the lab. You do not need to list things like calculator, iPad. Your diagram really should be labeled, like label the components in the diagram. If it's just like something that my 4-year-old could draw, then I'm not really impressed, and it probably won't get full points. You don't need to spend a ton of time making it super artistic, but it should be recognizable and labeled. For the methods section, I do give a couple of examples here, so if you want to pause the video and read them, you could do that, or just look for the document in the drive. Requirements for graphs: minimum of a half page, title has to use words, it needs to be descriptive, right, fully descriptive so I could tell what it is. Just velocity, not really a title. Axes should have names in words and with units. Almost always you're going to do a scatter plot for this class. And if it's a linear graph, it's got to have a trend line. You may show calculations on a graph if they are related to that graph. It has to, the graph still has to be readable when you're done. All right, for this lab, this first lab that we're going to do, there is going to be some mathematical error analysis. So you'll use these two equations. Anytime something says to calculate a percent difference, that's this equation here. When it says average, it means of the data set. So not of the largest and smallest values, but rather of the entire data set. An example of that is given down here. The quote average that was used to calculate the percent difference among these three values was the average of all three values. For largest minus smallest, that would have been 9.85 and 9.72, and you can check my calculation yourself if you want. For percent error, experimental is what you actually calculated. Theoretical is what the accepted science value is. Like if it's gravity, 9.8 or 9.81 is a little more precise. Discussion. You will always talk about the significance, and it should always relate back to the purpose. The lab was supposed to demonstrate a specific thing. If you demonstrated that, you say, I demonstrated it, and here's why. If the answer is no, you are allowed to say no if it really didn't demonstrate it. Similar to the theory section, the discussion section will almost always have specific questions that I want you to address, usually about your results. So make sure you answer those. And then you're always going to discuss at least 3 significant sources of error. Always at least 3. And the 3 varieties of those are mentioned here. All right, now you may have noticed from some of my critiques that I do care about good writing and I do care about good formatting. I don't want a lot of white space. I don't want, the things that Timmy had, like, I took a screenshot and I left all of that garbage in, like all of this. I don't want that. If it looks good, then that makes me think that you cared about it and you spent some time on it. And that actually does factor into your grade. Timmy He got no points for formatting because it was so bad. Write like Gunter, don't write like Timmy.